Hey guys, Mr. Bowman here. Today's learning objective is in blue, and we are trying to find the area of a trapezium. So a trapezium may be a new word, but just to recap what that means. So we've already looked at, well, how do we find the area of a square? We then moved on, well, how do we find the area of a rectangle? Rectangle. And the last four-sided shape we looked at was the area of a parallelogram. We then moved on, well, how do we find the area of a triangle? And today's one, we're going to be going over the area of a trapezium. And I've drawn an example trapezium below. And the reason trapezium, and the reason this one's really important is because it's going to have a different and unique formula. So we also learnt, well, those first three shapes, that area was equal to base times height. The last shape, or the triangle, the area of that is equal to 1/2 of base times height. And today's formula will be the most complicated of all, and I'll write it down. I'll write it down at the top actually. So the area of a trapezium is going to be equal to A plus B divided by 2 times height. And we can see that's a lot more complicated than the two formulas we've been given. So I suppose the first thing we need to look at, well, what exactly is a trapezium and what are its characteristics? So I've drawn an example here, and I've drawn another example here, and maybe a final example. Yeah, I'll actually get rid of that last one and we'll draw a bigger version of it. So let's have a look. What characteristics do trapeziums have? So the first thing to note is there's always a set of parallel lines. So we can see the top line and the bottom line there. Those are parallel. The top line and the bottom line and that one, they're parallel. And we've got the two side lines. They are parallel there. So those parallel lines I've identified, they are the A and B values for our formula. So that side there would be A and B, and then A and B. So however long those sides are, those are numbers that form part of the formula. And the other bit of information we have, well, we need to know how tall or how high is our shape. And that shape is always represented by the height or the distance between A and B. So the height there, and in this case, because A and B are sideways, the height also goes sideways. So just to recap, A and B, they are the parallel lines, and H is the distance between them, between the parallel lines. So hopefully that's beginning to make sense. So that's how we look at the shape. So I've got an example up the top that we're actually going to get in. We're going to find the area of this trapezium for. So the first step is we need to label the sides of our shape. We need to label A, B, and H. And those letters, they all come from the formula that we're given. So just to recap, A and B, they are the parallel lines. So which lines are opposite each other? And for me, it looks like that top line there and that bottom line there. So that means we're going to say A, we're going to put that in brackets at the top, and B, we're going to put that in brackets down the bottom. The distance between these two is the height, and that's going to be the 11 centimeters up there. So let's go in and let's try to calculate the area of this trapezium. So the area, I always like to write the formula down as A plus B divided by 2 times height. That's going to be A, which was 8 centimeters, plus B, which was the 10 centimeter side. That's going to be divided by 2, and then we're going to multiply that by H, which is the 11 centimeter side up there. We're then going to do the math in relation to that. So 8, we're going to start off by the top. 8 plus 10, well, that's going to be 18. That 18 is going to be divided by 2, which will be times by 11. 18 divided by 2 is 9 times 11, and then 9 times 11, 99 centimeters squared. And that there is the area of the trapezium that we're looking at. So if you haven't already, I encourage you, please get down some of the notes that we've been looking at. So we've got a formula, we've got some examples of trapeziums, and we've labeled them A, B, and H, and we've got a definition of what A, B, and H are. And we've also finally got an example of how to do that. So if you haven't, make sure you get those examples down. I'm going to pause the video, I'm going to clear our working, and then we're going to do 3 more examples together. And then once we've done that, I'll let you get into some questions yourself. Okay, guys, we're back. We've cleared all the video and all the work from the previous section. We're now going to get into some more questions. So I've got 3 trapeziums, including 1 extension trapezium down the very end, which some of us might be interested in. So first step, we need to identify which one of the parallel lines, because they're going to be A and B. So for me, it looks like the top and the bottom, those 2 lines, they're going to be A and B because they are parallel to each other. And that means the last dimension here, which is H, and because H is the horizontal height there, we'll be able to use that number. So let's write down our formula. So the area is equal to A plus B divided by 2 times H. A is 4, so we're going to put 4 there. B is 6, so we're going to add 6. We're going to divide by 2. We're then going to multiply all of that by 3, which was the height. So hopefully you understood where all those numbers came from. We're then going to add the 6 and 4 together. So that's going to become 10 divided by 2. We're going to multiply that by 3. That there is going to become 5 times 3. And we're going to finish up. That's going to be 15 centimeters squared. So hopefully that makes sense, and hopefully you understood where that came from. So we're going to move on to our second one. So this here is a trapezium that's been moved sideways, and we can tell that because if you have a look, where are the parallel lines? Well, that line and that line look parallel to each other, so it means it's been switched around, and it means the distance between them, which appears to be 5, would be the height. So let's go away and label them. So the parallel lines would be A and B, and the height down the bottom would be H. And we can do a similar process to what we did for the previous question. So the area is going to be equal to A plus B divided by 2 times height. A is 7, so that's going to be 7 plus B, which is 11, divided by 2, and that's going to be multiplied by 5. 7 plus 11 is 18, divide that by 2 times 5, 9 times 5, and that means that comes to 45 meters squared. Noting that this time around it's meters squared as opposed to units, centimeters squared from the previous question, and that's because the units in the question had changed. They're of a different measurement. So hopefully you understood that, and that made sense. Apologies about the funny tick there. We're now going to move on to our harder question, our extension question, and we're trying to find the shaded area of this shape. So what you can see is we've got a big trapezium around the outside, and from the middle we've actually carved out or taken away a smaller trapezium from that. And the way we need to approach this question, so the shaded area is going to be the big area minus the small area. So we're going to need to calculate those all separately. So let's find the big area first. So the big area, that's going to have the same formula. It's going to be A plus B divided by 2 times height. So let's have a look at the big shape. So we can see it looks like the parallel lines are top and bottom. So that would be A and B. So that means it's going to be 16 plus 10. So 16 plus 10 divided by 2. That's then going to be multiplied by the height, which is 10 centimeters times 10. So that's going to become 26 divided by 2 times 10, which is 13 times 10, which is 130 centimeters squared. So that's the area of the big shape, and it does include that middle portion there. Now what we're going to do, the next part of the formula, minus small, we're going to find the area of the small prism and take it away, just like the diagram has done. So let's go the small area. And same thing, I always write down my formula first. A plus B divided by 2 times height. So A in this case, so we've got to figure out which ones are the parallel lines. So again, it looks like it's the top and the bottom. But just a reminder, it can be the two sides. So that's going to be 7 plus 9 divided by 2 times 3. That there is 16 divided by 2 times 3. That there is 8 times 3, which is 24 centimeters squared. From there, we're going to carry on with our big minus small. So the big one was 120 and the small one was 24. When we subtract those from each other, that becomes 106 centimeters squared. And that would be the shaded yellow portion of that shape. So hopefully you understood and where you got that question from. And it was a very tricky question. It was an extension question. So well done if you got that. So hopefully, guys, you found today's video useful. Hopefully you can say you know what a trapezium is and you know how to calculate the area of a trapezium. Now, let's get into heaps and heaps of questions. Thanks for watching, guys.